Yeah. Hello, Puneet. How are you?
Hi, sir. I'm fine, sir.
Yeah.
Sir, what's today's topic?
Yeah, Puneet. Today we'll discuss about a servo motor. Puneet, can you see my screen?
Yes, sir.
Okay. So, as I mentioned, today we'll discuss about servo motor. So, yeah, let us have some understanding on this before we get into details. Puneet, you know the DC motor, right?
Yes, sir.
Okay. So, can you tell me what are the applications of DC motor?
Sir, like DC motors are used in our previously made line following robots, obstacle avoiding robots. Like it's like a
To drive the tires of those
yeah,
robots.
it's like a motor which is used to like attach wheels and it can move objects
Yeah,
like a car.
exactly. Exactly. So, yeah, that is the purpose of the DC motors. And now we're going to understand about somewhat advanced motor with closed loop control system in that. So,
Sir,
of course,
can
yeah,
servo motor also be like DC motor?
mm, something like that. We'll understand exactly.
But
So
like,
basically, yeah,
can
servo
it
motors,
carry the weight?
of course, uh, weight, load, and all are relevant to the torque. It is something related to the torque of the motor.
Okay,
Yeah,
sir.
see, basically these DC motors are little bit of high speed motors, and we put a gearbox on that and reduce the speed and increase the torque. And higher the torque, then that's how we can use them in the projects. So yeah, we'll touch on those topics also. Now let us get into the details of difference between the DC motor and servo motor. Fundamental differences I can say you on that first. See, servo motor is a it's a closed loop system, whereas the normal DC motor what you use for this mobile robot movement, right? Like where you connect the tires. These are like open loop systems. Now, what is this open loop system and closed loop system? So I can give you one simple example. Like, so imagine Puneet, like your performance in school, uh, that need to be informed periodically to your parents as well, to how you're performing in the class, uh, all the positives, if any improvement required, and all that. So sometimes whenever you go through any exam, when you get a result, or even something like that, it will be usually communicated to your parents, right? So usually what the class teacher will be doing, she can mention a note in your diary, and it will be sent to you, so that your parents can read the note and acknowledge that, correct? So yeah, so here we can say like your father and mother can see the diary note, acknowledge, and they'll send it back to the school again. So so this is like a closed loop system now. Your performance is evaluated by a teacher, and she make a note in the diary, and she will send to you, so that you can get an acknowledgement from your parents. And then again you return the diary to the class, you show to your ma'am. So here what's happening, your parents are getting a constant feedback from your teacher. about your performance in the class.
So it's like input and output.
Not exactly, not exactly. It is like updating the status, what's happening on time to time. Yes. So yeah. So this I say as a closed loop system. Now open loop system is something just something. If you break the system, right, it is something open loop system. Imagine if teacher don't send a diary note to your parents. Sometimes they may miss the updates, right? So in that case, there is no proper feedback about your performance from classroom to your parents. So and there is no proper feedback. And at the same time, imagine if your parents don't send any diary notes to the ma'am. Even that way also there is no communication from other side. So it is like an open loop system. So feedback is required uh, to check whether the intended purpose is serving or not. So that is the smartness of the servo motors. They take the feedback and check whether it is meeting the requirements or not. If any corrections is required, it will correct the signal and send it back again. And constantly it will keep checking the signal. That's how what happens in the servo motor. But in open loop system, it won't happen. For example, like if you supply current to the DC motor, it will start rotating, right? The shaft of the motor will start rotating. But in return, the motor is not sending any kind of signal back to the any other device. Imagine if the motor is controlling with a drive will not be receiving any kind of feedback signal from your motor. So that's how the open loop systems are working. Anyways, I hope you understood the high level difference between the closed loop system and open loop system.
So that
Now,
means like the servo motor will send the signals to the controller.
yes, internally there is a controller, and and the controller receives a signal from a sensor there. So we will see a construction on high level how it looks like. Let me clear my screen. Yeah, yes, here we go. So even a servo motor contains a normal DC motor. We are talking mainly about a toy servo motors. Okay.
So how does a servo motor look?
Yeah, servo motor looks like a small plastic block. For example, I have already made some images ready for you. Yeah, yes. Can you see this is a servo motor? How it looks like? You can see servo motor contains a normal DC motor, and there is a control
Sir,
system
I'm
board
not
on
able
that.
to see the servo motor.
Okay, just a minute. Just a minute. Yeah, can you see my screen now? Can you see now?
Yes, sir.
Yeah. So here it is. Yeah. So servo motor also contains a DC motor connected to a control system board, and even there is a potentiometer, which is a rotary sensor. And this is a sensor which will be sending the feedback signal to the control system. And
Yes.
by the way, this potentiometer shaft and DC motor shaft are connected with a gearbox. And of course, the purpose of gearbox is to amplify the torque by reducing the speed. And And this control system board will be receiving the reference signal from external source like a servo motor controller or even a microcontroller, which will give a reference signal, which in terms nothing but the desired angle to which the servo motor need to position the shaft. So yeah, now we'll go back to the So can you see my board now?
Yes, sir.
Yeah. So this is a DC motor, and as I mentioned, it will be connected by a gate train to a potentiometer. So potentiometer, you know, right? It's a variable resistor.
Yes, sir.
Yeah, and now here it is acting like a rotary sensor. It will have three terminals, right? Positive, negative, and wiper. Terminal 1, wiper, terminal 2. So this wiper will be giving a reference signal. There will be a control system board. So DC motor is connected to the board, and even the reference signal will be sending to this board. Now the user, imagine now user is using this servo motor to steer his remote control car, RC car steering. Maybe he want his tires to just make angle around 30 degrees, imagine. So then the user can send a reference signal as 30 degrees, but the signal will be in the form of a PWM, which is nothing but pulse width modulated signal. So it looks like a square wave, more or less, like with, of course, each cycle is around 20 milliseconds, and the of course duty cycle will be there, like depending on the percentage of high signal and the low signal. This I will explain a little bit later. Now, yeah, once the user sends a PWM signal, of course he can use a microcontroller also for doing that, or even a servo motor controller. For example, we can say, let us say he's using an Arduino microcontroller.
Sir, for the servo motor, can we use Arduino Nano, or just a specific board for that?
No, yeah, any kind of microcontroller is okay, as long as that microcontroller will have a PWM pins on that, because we need to generate a PWM signal to drive the servo motor. Okay. So yeah, once the signal goes to the servo motor controller, of course there will be a comparator which will compare both these signals. For example, let me differentiate this one with a red color. Okay, and this one with something like a green color. So you understand the difference between these two signals should be 0. Then this servo motor shaft will stop rotating. Imagine if there is some error. For example, like servo motor is at particular, if it is at a 90 degrees now, but the user want it go to 30 degrees. Then what is the error now? Like something like 90 degrees minus 30 degrees is the error. Something like 60 degrees. So the servo motor shaft need to rotate 60 degrees so that it can match the desired angle that what the user wants. Until it reaches to that particular angle, servo motor will keep rotating, and once if it reach, the error will become 0, then servo motor will stop rotating.
Sir,
Anyways,
like after the servo motor reaches its destination, will it again turn back, or it will stay in the same position?
it will, once if it reaches the destination, it will stop. It will be in the same position. You cannot.
Sir, can we program it like after going to its destination, can it come back to the home position?
Of course. For example, for a couple of seconds, you can send the signal like 30 degrees. then it will go to the 30 degrees, and then after that you can program it back again something like 90 degrees if you say, then it will again go back to the 90 degrees. So it all depends. Uh, you can send all these signals in sequence. Servo motor will keep changing its angular position accordingly the signal that it receives. And of course there should be some time interval because even the servo motor needs some time to react, right? If you can give the time for servo to react, it will reach the destination, and then it will respond to the next angle, and it'll keep on working continuously. And generally you know these servo motors are used everywhere, like for example, see these industrial robots, even even RC aeroplanes, many applications. Uh, in many of the automated equipment, machinery, servo motors are used very widely. And generally, for if you say this industrial robots, right, these are 6 degrees of freedom manipulators. They'll contain 6 servo motors.
Sir, like how
And
many degrees of freedom it is, those many servo motors it contains?
yes, yeah, that I mentioned already. Yes, that's correct. You're right. So yeah,
Sir, is there only one thing called toy servo, or is there any other servos?
yeah. See, like toy servos are the servos which you will be using it as a student, right? You'll be using the toy servos, and of course, industrial applications. They use a different high torque servos because of requirement. So, anyways, for our case, we'll be using a toy servo, and I can show you the block diagram on high level. As I mentioned, right, the control signal will be the reference signal, which can be generated by a microcontroller or a servo motor controller, which is nothing but a pulse width signal, as I mentioned. And now it is converted to a voltage, or something like an analog signal now. And there is a comparator. Comparator will be comparing the signal from a potentiometer, which is connected to the DC motor through, of course, the gearbox. And now it will see the difference, and that difference will be amplified and it will be sent to the motor. So this is the job of that control system board. And till the error becomes zero, this process will continue, as I mentioned. And even here you can see one more image where it shows a DC motor here, right? A low torque, anyways, but it will be, but torque will be get increased because of this gearbox. And a potentiometer is a sensor, rotary sensor here, and it is connected to the control system board. So that is how it works. Anyways, in coming classes, we'll be doing a couple of projects, and even I'll teach you how to control the servo motor using an Arduino board, and even of course with the servo controller as well. And even we'll be doing the 1 degree of freedom robotic arm, and then 2 degrees of freedom robotic arm. And even we are going, yeah. Sorry, Puneet, I cannot hear you properly.
Sir, actually, how can we do the 1 degree, like 1 degree of freedom robotic arm? Because like the robot has to have two joints, right? So it can't just move in circle, or it just can't go down and come up.
Yeah. You're right. But see, since it's a learning phase, we'll start with one DOF where we'll be controlling only one angle, one theta, and then after we can add two servos and we can control theta 1 and theta 2, and then we can increase the motors, and then the complexity will increase, right, to understand these variables again. So we'll start with 1 degrees of freedom, and at the same time you understand we will be using a servo motor for our maze solving project also, where you have
Sir,
used the
but Maze solver is over, right, sir? How are we going to use servo motors?
We'll use a servo motor in maze solving robot that will mount one ultrasonic sound sensor on the top of servo motor so that it can sweep some like 100 degrees of angle, and it can check the obstacles like front, left, and right, and then it can take a decision where to move on. Got it? Yeah. Sure, Puneet. Then we'll continue next class, Puneet. Then, okay?
Okay, sir. Bye, sir.
Yeah. Yeah. Bye. Thank you.
Bye, sir. Thank you.